use your calculator to find your answer here. And again, hopefully your calculator part is easy, right? The hardest part is to find the N, the P, and the X. For me, to me, I think that's the hardest part. So question here, any question related to this 3 item? All right. If you don't have a question, let's take a look at D, right? Would it be unusual for 18 or more Fortnite player or between the age group of 10 to 25? So again, this is basically, this is what they have is we take out 20 people, we sample 20 people. Will it be unusual that within this 20 people, 18 or 19 or 20 of them is between this age group? That's the question they ask you. But again, because of this thing here, reminder, because of this item, which is 18 or more, is the same as more than or equal to 18, right? Because of this 18 or more, meaning again, the 18, we have to use it, which is, if you remember, or if you go back to that chart, I did not have the chart with me here, but if you go back to the flow chart later on, when you see more than or equal to or 18 or more, meaning again, we have to, the X will be 1 less, right? Because the 18 is on the right-hand side, which is we tell our calculator, calculate to me because my calculator can only calculate the 0, the 1 up to the endpoint that I have, which is again, the up to the endpoint I have is the 17. Why? Because the 18 is what I'm looking for. I'm looking for the 18, I'm looking for the 19, I'm looking for the 20, right? So again, looking at this thing here, we can do this, which is again, we can say, calculate me the binomial CDF, which is the 20 and 0.53 up to 17. And again, whatever this answer is, this is not my answer, because whatever this thing is the combination of the 1, the 0, the 1, the 2, the 3, the 4, the 5, the 6, all the way up to the 17. Now, to find 18 or more, I have to take 1 minus this, which is 1 minus this will give me, again, reminder, ladies and gentlemen, reminder that your calculator, if you subtract this, your calculator will give you 5.14303 e to the negative 4. The probability is not 5.14, okay? E to negative 3 tell you that this thing here, the decimal that you have to move 4 places to the left-hand side, which is, again, the decimal was right here, 5.14, which is the decimal is right here. I have to move 1, 2, 3, 4. Because of this negative 4, I have to move the decimal 4 places. That's why I have 0.0005, okay? So now 0.0005 is this reminder. How do we know if it's unusual? If it's less than 0.05, meaning if it's less than 5%, we consider that it's unusual. Is this probability less than 5%?
Yes.
Yes. So we say that it's very unusual, right? I can put very because it's very, very small. This is 10,000, right? This is 10,000 of the percent, right? 10,000 of the percent. So looking at this thing is not even 1%, right? So again, we just say, yes, this is unusual. And again, even up here, go back to A, this is also unusual too, right? Because 0.049 is not 0.05, right? 0.0497, this is more than 0.05, so this is unusual. This is also unusual, right? 0.01 is less than 0.05, right? This one is 19%, so this is usual, okay? But again, that's the idea of unusual here is, this is the idea of unusual here, which is, again, if it's less than 0.05 is unusual, okay? So again, question with this particular problem here.
Mr. Tran, I have a question. For part D, the question says, would it be unusual for 18 or more, but X is 17. So I'm just a little thrown off on.
Again, 18 or more, remember 18 or more is if you want to think about this way is, we want to know if it's possible, or you know, if it's unusual, if we out of this 20 player that we sample out, 18 of them will be in between the age group of 10 to 25, or 19 of them will be in the age group of 10 to 25, or 20 of them, 20 out of 20 player will be in this age group. So because of the 18 or more, meaning we have to include the 18, the 19, and the 20. So if you want to, you can do this, which is you can do the binomial PDF for 18, the binomial PDF for 19, the binomial PDF for 20 individually, and then add them up. You will get this answer right here. But the calculator, if you use the CDF, it's cumulated from 0 up to your endpoint. So do we go all the way up to 18? We cannot go up to 18, because if it's up to 18, your 18 will be on the left-hand side, right? Because of 18 or more, meaning we have to include the 18, right? Let's see. Let's take a look at this thing here. This is what I mentioned to you last time, right? So 18 or more, right? Disregard the 21 to 30, right? Up to this thing here, which is, do you agree that 18 or more is this group of people?
Yes.
So 18 or more is the 18, the 19, and 20. That's what we want. Your calculator, my calculator, cannot calculate just that group. My calculator calculates from 0 all the way to my endpoint that I want. So instead of go up to not 18, well, 18 is in this group, so I cannot include the 18 in it, right? That's why I told you if it say 18 or more than or equal to, we have to use one less. My endpoint is one less than that item.
Okay.
Is that making sense?
Yes.
So if that's why, you know, like I mentioned, you can do the individual 18, the individual 19, and the individual 20, and then add them up. You still have the same answer. But because we use a CDF, we go calculate from 0 to 17, and then if I know this group is equal to 0.999999, I just need to take one minus to give me the leftover. And that's why I say that the hardest part is to identify the hardest part is to identify the endpoint, right? And that's why I give you this 3 item right here, which is reminder, fewer than, we use one value less. 18 or more, we use one value less. If it's just more than, we use whatever that value they give us. That's why that's what I mentioned with my floating chart. Okay. Question. Any other question before we move to not another example? We go back to this example a little bit, but we have one more item that we need to consider with this binomial distribution. So question with this thing here before we move on, nothing new, just add on. All right, let's take a look at the next item, which is, again, with binomial distribution, similar to 5.1, with the probability distribution, we have to find a mean, we have to find a variance, and we have to find a standard deviation. So with this binomial distribution, we still have to do that too. We still have to find, they will ask you to find a mean, they will ask you to find a variance, they will ask you to find a standard deviation. But a little bit easier for binomial distribution is this. To find a mean for the binomial distribution, all you need to do is take the n, multiply to the p. Whatever your n is, multiply to your p, that will be your mean. So again, how do we find the n? Well, the n is the total. How many people did we sample? How many items do we have? The b is the probability that you successfully have that item or have that person, okay? And the variance is this, which is n times p times 1 minus p. And again, this author, he used 1 minus p. If you Google search, or if you try to search them for binomial distribution, some of the other author, they say n times p times q. The q is just the failure. Okay. And again, what is 1 minus p? 1 minus p is the failure, the complement of p, right? which is again 1 minus p, which is the same two number. And again, the standard deviation is a square root of n times p times 1 minus p. Okay, so basically this is the three item that you have, which is again on top of everything else, you have to remember this formula. Again, 5.1 is easy. 5.1, you do the 1 volt stat, the L1, L2, 1 volt stat, and they find you the mean and the standard deviation. But by normal distribution, we don't have that item, so we just using what we have, which is again, n times p will be your mean, n times p times 1 minus p will be your variance, and a square root of your variance is your standard deviation, which is a square root of n times p times 1 minus p. So again, looking at this thing here, hopefully you guys see that the calculation is easy, right? I use, again, I use in the same Fortnite data. So according to businessofapp.com, 7% of Fortnite players have made an in-game purchase, right? So again, whoever played this game, Fortnite, 70% of them have spent some money in this game, right? A sample of 25 players are chosen at random. Now they ask you to find the mean, find the variance, and find the standard deviation, right? So again, the different problem, last time they will, if the previous question, they would say, well, if 25 people are chosen, what is the probability of exactly seven of them spent money in this game, right? So again, looking at this thing here, this is what they have is find the mean, which is again, like I mentioned to you guys, 5.2, before we can find anything, the two things we need is we need a n and the p. And again, if the other question, you need the x. But this question, the mean, the variance, the standard deviation, we don't need any x. There's no x given. We only need the n and the p. So basically, this is what they tell you is, again, if I have 25 people on average, which is the mean, right? On average, out of the 25 people, on average, how many of them spend money on this game, which is the mean is basically n times p, which is n times p will give me 25 times 0.70, which is, again, you plunge in your calculator, on average, 17.5. So again, 17 or 18 people, right? On average, out of 25 people, 17 or 18 of them spend money in this game. Everybody see that? To find a mean compared to the previous problem, exact, more than, few than, this one here, hopefully you guys see that it's easy, right? Find a mean, you take the n times the p, right? If I have 100 people, on average, 70 of them, right? This thing here, basically 70 out of 100 will spend money in this game, okay? So what is the variance? How to find the variance? Again, the variance is n times p times 1 minus p, which is, again, 25 times 0.70 times 1 minus 0.70, which is, again, 25 times 0.70 times 0.3, right? Which is, again, how do I get 0.3? It's basically 1 minus 0.7. That's what my 0.3. And again, 0.3 and 0.70, that's 1, right? The probability of success and the probability of failure, which is, again, you either success or failure, which is you add them up is equal to 1 whole, right? But again, look at this thing here. Everybody see that 25 is my n, 0.70 is my p, 0.30 is 1 minus p, which is, if I multiply this thing here, I will have the variance of 5.25. And again, how do I find the standard deviation? Whatever my variance is, I take a square root of that, which is a square root of 25 times 0.7 times 1 minus 0.7, which is, again, 25 times 0.7 times 0.3, which give me a square root of 5.25, which give me 2.2913.
Can't you just square root the b?
Yes, that's it. That's all. Again, that's the difference between the variance and standard deviation, right? The variance, you square root the variance, you get the standard deviation. You square the standard deviation, you get the variance, right? It's the same concept as before. The rule of variance and standard deviation is the same as before. It's just that now the information provided to you guys, the information presented to you guys is a little bit different. But again, as you can see, hopefully the mean, the variance and standard deviation is doable. So let's take question before we take a look at the last example. So let's jumble everything around, put everything together, right? This is your typical test question, homework question, quiz question, final exam question, right? So let's take a look at this thing here. I just took this question from the book, which is again, Big Babies is the title. The Central for Disease Control, CDC, and Prevention report that 25% of baby boy between the age of 6 to 8 months, right? 6 to 8 month old in the United States weigh more than 20 pounds. A sample of 16 baby is 30, right? So again, looking at this thing here, again, 6 to 8, that's just a category, right? The category of the age. So we don't care about that number. Looking at this introduction, we can see that again, the two number, again, the 20 pounds is also just a measurement. We're not using that, right? So again, the only two number that we using or we taking out of this thing here is, hopefully you guys see that the N is equal to 16 and the P is equal to 0.25, which is 25%, right? Again, that's the, like I mentioned earlier, you know, your goal is try to see what number is useful and what number is useless, right? 6 to 8, that's just category. 20 is all the baby that we took out is 20 pounds or more than 20 pounds, right? Well, not more, all. We just took out 16 of them, okay? So now let's take a look at, you know, dissect this again, which is, again, if you read this thing here, once you dissect that we need the 16 and we need the 0.5, for A, we see exact, right? We see exactly 5. So exactly 5, we know that this will be a single point. And if it's a single point, do you agree that we use in the PDF, right? PDF. And again, what is my X? My X is whatever that number, whatever that value is, that will be my X. Which is, do you agree that because exactly 5, my X is 5, I use the PDF, which is binomial PDF. And the answer is whatever, if I type this in correctly, the calculator will give me the correct answer, which is again, 0.1802. Question with A here. Anyone does not have 0.1802. All right. What is the probability of more than? What is the probability of more than 6 baby weight more than this, right? What's the probability of more than? So hopefully you guys say, oh, more than. Is this say more than or equal to? No, right? It just say more than 6. And if you remember, more than 6, meaning again, the 7, the 8, the 9, the 10, all the way up to the 16, right? That's more than 6. So if you remember the more than 6, the endpoint for the more than 6 is whatever the number they give me, that is my endpoint, which is more than 6. I go up to 6, right? My calculator can calculate the 0, the 1, the 2, the 3, the 4, the 5, and also a 6. Because remember, more than 6, the 6 is not in that group more than 6, right? So my endpoint is up to 6. So now, reminder, more than 6, I have to use CDF, but is the answer from the calculator? Hopefully not, right? Why? Because again, this is what the calculator give me, but reminder, whatever you have to subtract from 1, because whatever your calculator give you, this is the left-hand side. This is the 0, the 1, the 2, the 3, the 4, the 5, the 6, unless you have the advanced one, unless you have I think like a CE something. But anyway, given this thing here, you have 1 minus the answer from your calculator, which is again, the probability of more than 6 baby weight more than 20 pounds is 7.96%, okay, or 0.0796, roughly 8%.
Excuse me, Mr. Chen.
Yes.
So they asked like more than 6, so why we have to including 6 in it?
Again, remember, more than 6, your calculator calculate, again, let me give me 1 second. Remember, more than 6. I should just do this. Give me 1 second here. Remember, more than more than 6. Think this is. So again, you can always draw your number line. Your number line is always So we have is it
16. 16.
16. So again, this is the group of people. This is the group of baby that is more than 6, right? 7 to 8 all the way to 16. So your calculator can only calculate up to the endpoint, right? So if you calculate up to 5, the 6 is left out, right? So remember, more than 6. 6 is not more than 6, right? 6 is not more than 6. So 6 is on the other side. It doesn't fit the description of more than 6, right? So again, think in terms of the number line, right? You either calculate fewer than, right? If they ask you fewer than, which is again, this is if they ask you fewer than 6, which is fewer than 6, this is the item fewer than 6, right? Fewer than 6, you calculate, which is, I told you that fewer than 6, we do 1 less, which is again, this item here, right? Which is your calculator can do that. If it's more than 6, which is again, if it's more than 6, which is this group of number that is more than 6. But if your calculator calculate up to and include the endpoint, right? Is count up to and include the endpoint. So we cannot just go up to 7, because if you're up to 7, you include the 7 already, right? So you have to go up to 6. Is that making?
Oh yes, thank you.
And again, this is the slide that, not this slide here. This is the slide that I mentioned earlier, right? Which is again, if it's fewer than, the x is 1 value less than what they asked you, right? Fewer than 6, then the x will be 5. If it's more than, the x value is whatever the number is, whatever the value that they given you, that's your x value, right? That's so if they say more than 6, which is the x value is equal to 6. So again, this is the flow chart that I made, and I told you that again, I will post this later so that you can see, you can follow this flow chart to see what is your x value. Okay. So again, instead of drawing a number line, if you can remember this flow chart, then it will be a little bit, But after you practice a few times, you can see that more than 6 is, you just use 6 because your calculator calculate up to 6. Okay. Let me go back to this one here so I can go. So again, let's go back to that problem. Sorry. So again, exact 5 we did, more than 6 we did, which is again, more than 6, we find up to 6, and then we take 1 minus that, right? So fewer than 3. Fewer than 3, what will be my x value, right? Again, we identify our n, we identify our p. Now what is our x value, which is reminder fewer than 3, the x value is?
2.
Is?
2?
1 less, right?
2.
Which is 2, right? Again, it has to be 1 less because we cannot go up to 3, right? Fewer than 3, unless they very trick you, they unless connect math trick you and they fewer than or equal to 3, and hopefully they don't do that, but they always challenge you. But again, once you can identify your x, hopefully you guys see that again, this is binomial CDF, which is again up to 2, and then your answer is the answer from your calculator, right? So again, obtain, the hardest part, like I mentioned, is to find that x value, right? If you can find that x value, the calculation part is hopefully doable. So would it be unusual if more than 8 of them weigh more than 20 pounds? So again, more than 8, which is more than 8, reminder, more than 8. What is my x value, which is again more than 8 is the same as more than 6, which is the x value is equal to 8, right? And then you plug this thing in, and again, reminder that this is not our answer because it's more than 8. We have to take 1 minus that, which is 1 minus this will give me 0.0075, which is this is clearly smaller than 0.05. So we say that this is unusual. Meaning again, if we have 16 baby that we took out, it's very unusual that 8 of them, half of them, right? Half of them. This is basically, the probability is only 25%, but now they want to say, oh, half of the 16 is more than 20 pounds, which is very hard, right? Because again, that's what they say right here, right? And again, hopefully you can compile this, which is the next item here is, what is the mean of the number baby who weigh more than 20 pounds? Which is again, how do we find this mean? Which is all we need to do is take the n times the p, which is you can see right here. You can see right here, which is the n times p, which is what is on average. On average is only 4 of them, right? On average, which is again, what is the average? The average is the meter, right? On average, only if we have 16 on average, only 4 of them weigh more than 20 pounds. But this thing here, they want to have more than 8 of them, right? Meaning again, more than 8 of them, which is almost more than half of the baby, which is that's why we say it's unusual. Because again, on average, it's only 25%. Now you want more than 50%. That's why it's unusual, okay? And again, standard deviation, what do we do? Reminder, the standard deviation is a square root of n times p times 1 minus p, which is again, you plug it in, 16 times 0.25, 1 minus 0.25, which is 0.75. So 16 times 0.25 times 0.75, this thing will give me 1.7321. If they ask you for variance, you take this thing and you square them, okay? But again, E and F. The only reason I give you this problem is just to show you that your homework, your quizzes, your test, they can ask you E and F together with this thing here. You're just using the N and the P. Okay. So again, question with A to F here.
Mr. Chen.
Yes.
So every time it says more than however many, you always subtract from 1, correct?
Yes. You subtract
Okay.
the answer from 1. Yes.
Okay. Thank you.
Any other question?